I want to review the concept of a logarithm and how logarithms work. So I've got several ideas here. For log base 2, 32 equals 5, the way this is actually interpreted is that this is your base, the answer to a logarithm is your exponent, and this argument, that's the result, that's the answer to this. In other words, this is the same as saying 2 raised to the 5th is equal to 32. So I have my base, my exponent, and then my solution. 2 raised to the 5th is 32. Now, using this concept, we can start to create little equations. And so for this one, I could write this, I could lead this into the idea that 16 to the 1/2 power is equal to y. And if you recall from previous lessons, if you have something that's raised to a fraction, if your exponent is a fraction, that's actually telling you to do a root. So in this case it would be a square root. So when I look at this problem, it's actually saying the square root of 16 is what? And that square root of 16, of course, would be 4. So 4 is equal to y. As I said, I want to do several examples of this, or ideas of this. So we got another one here. This implies that 5 raised to the -2nd, because here's my base, my exponent, equals what? And if you remember from algebra, when you have a negative exponent, this is a traitor. It's telling me that this shouldn't be a numerator, it should actually be a denominator. So I could write this, move my paper here, try to get some room. I could write this as 1/5 squared equals x, which would be 1/25 is equal to x. A negative exponent tells you to take that base and drop it to the opposite side of a fraction bar. A fraction as an exponent tells you to do a radical, and if this would have been like a 1/3, that would have been a cubed root. So I would have had an index of 3 out here. And so then let's look at another one, because that kind of leads to the next problem or next idea. I've got this log base 8 of m equals 1/3, which means that I could write this as 8 to the 1/3 equals m. And as I just mentioned a moment ago, if you raise something to a fraction, that's a root. So this is a cubed root. It's saying the cubed root of 8 equals m. And a cubed root means what times itself, so you have 3 factors of it, gives you 8. And if you're good with your numbers, you would recognize that 8 is 2 times 2 times 2. Which means this has the exponent to get out from underneath the radical, and so you'd say 2 is equal to m. I was able to bring that 2 right out from underneath the radical and get 2 equal m. And I've got one more example here. You have just enough room to work that out. I've got a base, an exponent, and a result. So this is saying 3 raised to the 3rd is equal to p/2. 3 to the 3rd is 27. And notice that it doesn't faze me that it wasn't just a simple m or x or y. This one had an expression here. It said p/2. Alright, so I can solve it. I can multiply both sides by 2. As I multiply both sides by 2, I get 54 is equal to p. And that expression idea opens up a whole concept of things we could do. We can actually call this 2x minus 5, 3y plus 2, p/2. You can put anything you want in there and then just actually solve an equation. This whole concept is just understanding how to work a logarithm. That's all we want to do there. Now we'll have a second video today. The second video is going to be properties. So there's some properties, some other things that we can do with logarithms that we haven't talked about yet. And that's what I want to focus on in the second video.